This demonstration, based on the theme Build in the Cloud with Confidence, highlights Amazon VPC traffic mirroring, allowing seamless operation of the NETSCOUT performance and security solutions which take advantage of rich packet data, aka wire data. A key benefit of Amazon VPC traffic mirroring is that it is set up at the AWS infrastructure level, independent of the compute in the workloads, rather than installing lightweight agents into guest operating systems on EC2 instances. In this demonstration scenario, we migrated some front and back-end workloads from the corporate data center to AWS to benefit from automated scalability and agility that AWS facilitate. However, consistent continuous visibility of applications, infrastructure workloads, and their dependencies in this hybrid environment becomes even more critical to optimize, troubleshoot, and ensure security. NETSCOUT call this visibility without borders and achieve this by leveraging universal wire data. Our software vStream technology, storing the packets and creating meaningful performance and security threat indicators, or smart data, consumed by our analytics platforms, IngeniusOne for network and application performance, and Arbor Threat Analytics for security insights. Amazon VPC traffic mirroring allows us to create traffic mirror targets, ENIs on the vStream, and set up traffic mirror sessions from our migrated EC2 instances to those targets. Let's see NETSCOUT Visibility Without Borders in action with Amazon VPC traffic mirroring. And take a look at what we can do with the smart data generated by vStream from the traffic mirrored sessions. vStream discovers all the applications running in the VMs, and the application monitor shows this automatically splitting the traffic into the traffic mirrored sessions, VNIs, or VXLAN. In this case, for the instance represented by VXLAN VNI 5104 session, one of the front-end service, we're seeing traffic volume distributions of REST API calls, MySQL, NTP, and Telnet traffic. IngeniusOne's service dependency discovery lets us visualize how the instances are communicating with each other, and also how they're communicating to the outside world. After all, this is a hybrid deployment. As an example, we're seeing RDP to a Windows Server instance talking to an app server, which itself is talking to database servers in the cloud and in the data center. But of course, there's a lot more going on that we've discovered, including communication to the important shared services, such as LDAP and DNS. From this automated discovery, we build service dashboards to help us organize the triage process for troubleshooting, especially in multi-tiered or refactored microservices-based apps. In this case, we have an app divided into web, app, multiple database tiers, as well as some of the shared services such as Active Directory, LDAP, and DNS. And each tile represents the performance of each of these tiers, which helps us with the triage process. In this case, we see problems with the database SQL server layer. Drilling down to the application service monitor reveals the monitored EC2 instances talking to two SQL Server databases, one hosted in AWS and one in corporate. The one in corporate, as it happens, is much slower than the one in AWS. Smart data sees both application response time and network latency, or RTT, both higher and therefore slower to the corporate database server. We can use this information to optimize our hybrid setup, where we place our workloads and what instance type we select. Additionally, we're seeing errors accessing the database. In this case, a straightforward user login error, but we can drill down further to see exactly what's going on, sessions and packet detail. We're also seeing that the packets are encapsulated in VXLAN on VNI 5101, which shows that the traffic is coming from one of the EC2 instances that we have traffic mirroring applied. Using the NETSCOUT top-down approach, our smart data gets us to the root cause and the packet detail so much quicker. So far, you've seen how smart data is used by IngeniusOne for network and application performance management. Now let's take a look how the same smart data is used by Arbor Threat Analytics to identify and investigate security threats. Let's log in to Arbor Threat Analytics, or ATA, and take a look at the security insights we get from smart data generated by vStream from the AWS traffic mirrored sessions. ATA detects many security threats, and the dashboard lights up when they are triggered. Here's some we're seeing right now on the affected AWS instances. External DNS servers, less secure protocols such as Telnet, weak ciphers in use, the presence of SMB1, which could be indicative of malware, and bad certificate policy, self-signed and expired certificates. Let's just examine one of these, external DNS servers, and investigate what's going on. There are many DNS servers, and one that stands out, 8.8.4.4, with regular violations. Next step, use host analysis to investigate that address, and we establish the instance doing the DNS queries, one of our EC2 instances. Then changing the focus, we discover that it's also talking to 4 hosts on different protocols, but unusually there's a larger amount of DNS traffic. From here, we drill straight to sessions, indicating a regular pattern of DNS traffic. The next click, we're down to packets, and we certainly get a sense for what's going on here. This is a DNS exfiltration attack, a rather clever way of using DNS to send out text records, which will be going to a rogue DNS name server. With this evidence, we can now do the remediation necessary to initially block this traffic and then clean up the infected source machine. One more thing. We can see that this was derived from traffic sourced through AWS traffic mirroring by virtue of the VXLAN encapsulation on VNI 5105. Another case solved with Arbor Threat Analytics, feeding security insights or smart data calculated by the vStream being fed by Amazon VPC traffic mirroring. As you've just seen, NETSCOUT Solutions, InGeniusOne, and Arbor Threat Analytics both leverage the same data source, vStream, which provides multi-purpose network application performance and security insights, providing cost-effective instrumentation in hybrid cloud environments. As digital transformation continues to accelerate and IT teams need to migrate workloads to the cloud with confidence, Amazon VPC traffic mirroring sessions, turned into smart data by NETSCOUT and used to achieve visibility without borders, is key to assuring cloud migration success.